Today we're going to talk about the hand metering unit that's used on the steering systems for wheeled steering for multiple reasons. One, it has a built-in follower network, or follow exactly what the steering wheel does and meter the oil to the actuator, the steering cylinder itself. And two, it provides us a backup means to physically move the actuator in case the engine dies. To start this off, I have a fixed displacement pump with a system relief of 4,000 psi running through an open center DCV. The DCV itself is 3 positions, 6 ways. I can see there's 6 ways, 1, 2, 3, 4, 5, 6 ways now. And I'm mechanically going to operate this DCV. When I move the oil either to this position or this position, it will go either left or right. So I have a double rodded or non-pressure differential steering cylinder in this case. And the only thing missing out of this is some means to center this DCV. So what I haven't drawn in here yet is there is actually a centering spring connected here to help center that. So when I let go of the steering wheel, that centering spring will center itself. First off, in neutral, all the pump flow is just going back to tank, unrestricted. Success with this particular system, how I've drawn it, and my steering cylinder is physically being held. Whatever position it's in is the position that it's being held at. Now, this is my steering wheel up here, and it's a very beautiful steering wheel that I'm going to physically operate, mechanically operated in this case. I'm going to physically move my DCV, and I'll just slide my DCV up. So if I slide my DCV up, then pump flow that was here goes all the way down to this particular way, which means it goes into this motor. So it's being delivered to the motor. Well, the motor is physically, mechanically connected to this follower sleeve on the outside of it. And that is to say it is a precision machined sleeve, just like this internal spool valve. This is just a rotary DCV. Even though I slid it, we actually rotate it with the steering wheel. So this is a rotary DCV or an orbital spool valve. So we open my DCV, rotating it, and the oil is supposed to go down to this motor, and the motor physically, well, the motor won't turn unless I can get oil out of it. And to get the oil out of it has to go into this actuator, which will steer it, providing I can get the oil out the other side. And if I go out the other side, I need to be connected to the tank. Well, yeah, that just means that really I have 2 actuators connected in series. What goes into this must come out, and whatever comes out, well, in this case, I have a non-pressure differential, then the oil going in this side is same as the oil going out that side, which goes back to tank. Great. The understanding of this motor right down here is that really it's only driving a follower sleeve. So there's a sleeve on the outside of this rotary spool valve or orbital spool valve. There's a sleeve on the outside of it that follows what the steering wheel asked it to do. And that is to say, if the oil goes down in here and this can move, then oil had to go in and displace one side to the other to move this. If oil goes in, then oil must have crossed this. If oil crosses this motor, then this motor must have turned. And then what happens is if the motor turns, it's mechanically connected to this follower sleeve, and it will catch up to what I've asked the steering wheel to do. The beautiful part about this is a G rotor motor, and it takes a lot of oil or displacement just to get one rotation of the motor. So in order to turn this mechanical drive one rotation, it actually has to meter the amount of oil going to this particular steering cylinder, which is beautiful. So what it does is it follows or catches up to the steering wheel. I turn the steering wheel a little bit, this follower network turns a little bit and catches up and then re-blocks or centers the DCV. If I keep turning the steering wheel, I keep ahead of whatever this motor is doing. And when I stop turning the steering wheel, the motor catches up and then blocks the flow of delivery. So this follower network is really to control how far I want this particular actuator to go. Do I turn the steering wheel? You know what? I'll turn it a quarter turn and I'll deliver enough oil until this motor physically turns this follower sleeve a quarter turn, which actually works out to about this far. If I turn the steering wheel some more, then it will open up, allow more oil to go down to this motor, and the follower sleeve will catch up, and then it will drive up to here and stop again. If I keep turning the steering wheel, then it will go up, 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 up until it hits the end of its stroke. And that is to say, if I hit the end of its stroke here, then oil can't go anywhere here. And I can physically open up the DCV with this centering spring. I can hold the steering wheel there, and I'm trying to get oil to go here, and this is trying to turn and follow what I've asked it to do, but it can't because there's no oil that can bypass this high pressure seal. Therefore, what I would see on here is whatever that system relief is at, it will hit 4,000 psi. And I will have 4,000 psi all through this whole system. It's trying to catch up with what I've asked it to do. And the only reason that it can't is because this physically you can't get any oil through it. So this follower motor can't follow what I'm trying to do. So I can hold the DCV open and I can hear the pump screaming because oil's going over the relief valve, the engine's being loaded down, all kinds of horsepower. And if I let go of the steering wheel itself, if I let go of the steering wheel, which is connected to this orbital spool valve, then the centering spring will recenter and this will become left and hold. But that is to say, the centering spring is completely different than the follower sleeve itself. The follower sleeve, I open up this rotary spool valve, I deliver oil down to this motor. The motor is driving the follower sleeve to catch up to what I physically asked this spool valve to do. So really, there's a housing with a rotary spool valve and a follower sleeve inside. And this follower sleeve is precision machined just like this spool valve. Rotates with no resistance, but it's physically, mechanically connected to this motor. So this motor has to turn in order to make this follower sleeve rotate. And the only way that this motor is going to turn is if this particular steering cylinder physically moves. And that's the concept for the hand metering unit. And if I was to go the other way, I could send oil in the other side of the motor. If I drive this down here, my follower network rotates the other way as long as the oil can get, and now instead of going to the right, now I deliver oil in the other way, which means the actuator moves to the left now. So this becomes left turn, the way I've drawn it, and the other one is the right turn. The basic understanding of this hand metering unit is that it physically has the ability with this built-in follower network to meter exactly how far I want the cylinder to go. Because without it, I have to open the DCV, I deliver some oil to the steering cylinder, but I would have to physically recenter the DCV to stop the flow of oil down to the steering cylinder. So it's good. I could feather it, I could let it run full tilt, but in order to stop the flow of oil to that steering cylinder, I got to recenter the steering wheel. Well, that might not be ideal. In some situations, it's actually very dangerous. So what we've done is we've built in a built-in follower network that says, hey, you turn the steering wheel this mount, I will follow what you asked me to do. I will meter the right amount of oil to the steering cylinder, and when the steering cylinder is moved the right amount, the follower network is recentering, blocking the flow of oil to the steering cylinder. Great. Quarter turn on the steering wheel is maybe 20 centimeters or 10 centimeters on that steering cylinder itself as a relationship. And that's the starting phase of it. Secondary to that is what would happen if we by chance lost this poor engine. Say it became air conditioned. If it was a Sage engine made by the same people who make Sage fishing rods, then you wouldn't have to worry about it. If we magically lose the engine one day while we're driving down the road, say it becomes air conditioned, and by air conditioned I mean a hole through the side of the block throws a rod or something silly, what would happen is I've lost my hydraulic supply. So this is a full-time hydraulic system that has no mechanical connection to the ground. So how do we safely steer this machine until we come to a stop? And that is to say, I could physically move this actuator again. I could physically move that. That's great. But the flow of oil, there's a positive seal. This is a positive displacement pump. So there's a positive seal inside of this some way, which is blocking the flow of oil from the tank. I can't even pull oil out of there. And that is to say, right now, I'm going to become the backup emergency steering system. I'm going to lose the engine on this. Well, remember that the operator is connected to the steering wheel. And by the way, that's mechanically connected to this rotary spool valve. I have a motor down here. So if I have a motor down here, really, all I need to do is drive this motor and physically turn it into a pump. Well, I can do that. And this is what it will look like in an ISO or a schematic. Often, it will be motor, pump, motor, pump. So it can be either way based on this design. Because here's what's really going on. Steering wheel's connected to this orbital spool valve, rotary spool valve, and the motor is connected to the follower sleeve. The two of these can work independently other than a centering spring. So what would happen if I was to draw in, for all practical purposes, a connection between that steering wheel and this follower sleeve, but instead of it being a solid connection, let's change it up a little bit. Let's make it have an allowable tolerance. So let's drive this with a pin, but let's let that orbital spool valve open up and shift all the way to one side or shift all the way to the other side. In other words, I'll be able to open up this orbital spool valve so much to deliver oil to this motor, and I can get a follower network. But if my engine dies, then if I crank this steering wheel even harder, it will come up against the stop, a mechanical stop inside, which now drives the follower sleeve, which is physically driving, which was a motor. So now what was a G-rotor motor becomes a physical pump. And the pump can deliver oil physically. Now that arm will physically be able to deliver oil in one side of it, providing I can get back to the tank. Well, that's good. I can get back to the tank, except where's the oil coming from? I have a problem. So if I have a problem, fix it. How do I get oil out of the tank? No problem. An anti-cavitation check valve. And now I can physically strong arm this and pull oil out of the tank to physically rotate the follower sleeve, which is rotating this motor, which is now rotating the pump because I'm turning it and delivering oil to my steering cylinder to have this safely come to a stop. So that's our hand metering unit. It's got a orbital spool valve delivering oil down to our motor when the pump's running and the engine's going, but when it's not, then I can still strong arm it, and what turned into ability to meter the oil to that steering cylinder now becomes a backup emergency steering system. And with that, let's go put a hook in the water and go fishing.